Hello guys, welcome you all for this end-to-end session of data science where we're gonna learn everything which is related to data science like AI, artificial intelligence, machine learning, deep learning, NLP, natural language processing plus generative AI, everything. So end-to-end, you guys gonna learn from a scratch to the master. So in order to become a successful data scientist, so hope you guys are enjoying. So we are enjoying a lot and we are learning a lot each and every day. So hope the same thing from you guys. So yeah, today's session is all about it's a continuation of previous session. So guys, if you guys doesn't watch the previous session, please make sure that you guys watch previous session. Not just a previous session, watch all the session that we have done till now so that you can have a better understanding of what we are talking. Okay. And one more thing, guys, please subscribe to the channel and press the bell icon so that you can get the notification whenever we are just uploading the new videos. So yeah, without wasting any time, let us jump into today's session. So last session we have introduced you what is PCA, the theory concept, it, and then black box of it. Some things we have seen. Okay. Today let us continue the session on PCA. Selecting principal components. PCA allows you to choose how many principal components to keep, effectively controlling the level of dimensionality reduction. This selection is based on trade-off between the reducing dimensionality and preserving the most important features, like most important informations. Okay, so PCA will say for your dataset how many dimensions you need to reduce. Okay, so that you will not able to, so you are not removing all the information. Okay, somehow you need to retain the information so that it is valuable, guys. Okay, I'm just saying it's true. Okay, there should be some information, not like PCA will reduce the dimension, so you should not reduce a 1 lakh column in a data set to only 10 columns. Then there is no point of having a 1 lakh column. That it is not gonna, I'm 100% sure, if you get only 10 columns from a 1 lakh columns, it's not gonna represent the entire data set. There will be some bias and variance will occur and your output will not be good. So there is a way to select this principal components, that is high dimension to low dimension. We need to specify how much low dimension we need such that it reduces the dimension and also it preserves the information. Let's see what are the techniques that we are having. Eigenvalue. Eigenvalues indicates the variance explained by each principal component. The larger the eigenvalue, the more variance it captures. Okay, put it in a simple manner, eigenvalue is a value which helps us to understand how many principal components we need. So that is when eigenvalue is larger, then there is more variance that is captured in the dataset. Okay, that is dataset is quite often varying. Okay, scree plot. The scree plot visualize eigenvalues in descending order, allowing you to choose an elbow point after which eigenvalues decrease rapidly. The number of principal components up to the eigen, like elbow, is good starting point. That's it. Okay. Once you get the eigenvalue, you need to plot it in the descending order. So there will be something called as a elbow curve. You will be having an elbow kind of curve. You need to take a data point, that is number of cluster, from this elbow point. That's it. That is what this scree plot will do. It plots the eigenvalues and pick the value for the cluster. Okay, like not a cluster, for a principal component, that is a components based on this plotting, that is scree plot. Next, cumulative explained variance. This is very important, guys. You can calculate the cumulative explained variance by summing the eigenvalues, choosing the number of components that captures a certain percentage of total variance, such as 90%, ensures the most of the data is retained. Okay, whenever you are just reducing, I said right, from 1,000 column I'm able to reduce to only 10 columns. You need to create a cumulative explained variable which need to have a percentage which is acceptable by the client and us. Consider we are having 100% information, we are just feeding to the machine to do PCA and it is returning with the information of only 90%, 100 to 90%. It is acceptable. But like if you apply a data set and the PCA is occurred onto it and you are getting only 20% of information out of it by using only two principal components, then there is no point of accepting it. So that is what this cumulative explained variable variance will do, tell you how much information it returns. Okay, so hope you guys can able to understand. So yeah, sir, is there anything that you need to add on it?
Yeah, so setting
Right.
principal component, guys, PCA, first of all, if you come to this session, so go watch 5 to 10 times all the sessions. do reinforced learning, and also build your long-term objective function with patience, persistency, consistency, and perseverance. And subscribe to our channels. Also press the bell icon so that you will get notification for each session, and give us feedback for each session so that we can continuously improve. So let us understand selecting principal components. PCA allows you to choose many principal components to keep effective controlling levels of dimensionality reduction. So PCA is if you see the fundamental nature of PCA is to dimensionality reduction, so that for keeping the relevant data, attributes, features in the model, and removing the which are not necessary. That is the fundamental principle for PCA, guys. If you remember this, that's it. The selection is based on trade-off between reducing dimensionality and preserving the most important information. Okay, so now eigenvalues. The eigenvalue indicates the variance explained by each principal component. Okay, the larger the eigenvalue, the more variance is captured. Okay, then you have to understand the second Sri plot we have, and that
Yes.
visualizes eigenvalue in a descending order, allows you to identify an elbow point, okay, and after which eigenvalue decreases rapidly the number of principal component up to the elbow, okay, is good for starting point. Then we have cumulative explained variance. You can calculate the cumulative explained variance by summing the uh, eigenvalue. Choosing the number of components captures a certain percentage of total variance, such as 90% ensures the most of the. So if you see, this is all about like when you're selecting principal component, okay, and these are the three elements which you need to remember, and we'll move to the other section. Let's keep learning deeply with long-term objective function. All these elements conceptually absorb the information, digest, and apply. So we are doing all of it, and there are more than 500 plus quizzes, guys. Go and attend. You will go to a next level of depth, understanding these all the concepts which you are learning, and mimic and imitate the projects. Complete all the assignments, quizzes, and write in the comment section if you still have question. Keep learning deeply. Thanks.
Yeah, guys. Let us move on to the next slide. Okay. So yeah, projecting data onto the principal components. Let us see what it is. Okay, so we're gonna see how the steps gonna work for this principal components. Okay, projecting data onto the principal components. The final step in PCA is it involves the projection of original data onto the selected principal components, creating a lower dimensional representation of the data. This projection represents the data in a new coordinate system defined by the principal components. Okay, what we will be doing here means we will be having a higher dimensional data. Okay, what we will be doing means we will create a line where we will be projecting all the data points there. Okay, that is what the final projection that we need to do. So it can be like a multi-dimensional data, but we need to make them to just project to only two dimension or a single dimension, such that we are able to represent the multi-dimensional data in a single dimension. Okay, I hope like you guys can able to understand, right? So we will be having a single line. Okay, it can be n dimensional data. We just need to project those data to only one line. Okay, that is what PCA do. Okay, when we define a component to one, okay, or two, we will be, for if it is one, we will be having only one axis, that is x. Two, we will be having x and y axis. Three, we will be having x, y, and z axis. Okay, hope you guys can able to understand, right? Now moving on, let's see what are the things that we are having. The project represent the data in a new coordinate system defined by the principal component. First is data transformation. The original data is transformed into a new coordinate system defined by the principal component. Yeah, true. We can have a data in 10 dimension, or like consider data is in a pentagon shape. We're gonna do and reframe it to only to a dimension that we need. That is called as data transformation. Next we are having something called as a projection. Each data point is projected onto the new coordinate system, resulting in a lower dimension representation. Okay, so we will be having a data in a 5 dimension. What happens means those 5 dimension will be reduced only to a dimension that we require. That is called as a lower dimension, and it is a new dimension. Okay, hope you guys can able to understand the projection. Okay, next we are having dimensionality reduction. The data is now represented in a lower dimension space, capturing the most important patterns and variance. This is very important. Dimensional reduction is not like I'm having 1,000 data so that I'm gonna reduce it to only 10 data. No, not like that. If you are reducing to only 10 features, it should be in a way that it can represent all other 1,000 features. That is what called as a dimensionality reduction. Okay, so this is what everything about projecting a data onto the principal components. Hope you guys can able to understand. So yeah, that is what about projecting data on principal component. Yes sir, over to you.
Yeah, projecting data into principal components. So, PCA involves projecting the original data into the selecting principal component, creating lower dimensional representation of the data. So, guys, why we do that? Why was a need of this thing? Or if we could do it without it, right? So always ask this question. If you find any concept, any algorithm, any technique, so you need to ask this question, why we need it? Because there is some problem. Because what it will do is it will create a lower dimensional representation of data so that performance of the model improves. That doesn't mean that you are going to reduce the number of data points. Okay? So you understand population. Population, your sample represents like the population, right? But you are not going to collect all kind of data, right? It should be according to the objective function, and then your model will be very heavy, bulky, right? Okay. So the projection represents data in a new coordinate system defined by the principal component. So first step is data transformation. So we transform data through principal components from higher dimension to lower dimensions. Okay. So the original data transformation into new coordinate system defined by principal components. So it is the only thing. You are actually, see, I'll tell you, simple example. Suppose you have lot of data files and you want to send somebody email. What do? You zip it, right? Or you put it in Google Drive, or you zip it. Zip will do what? It will reduce the dimensions for transportation only. Again, when somebody opens up, it will be in the same form, right? So you can relate it, but it reduces the dimensions of the data. It compresses kind of thing, but here it reduces the dimension and it picks the right ones which are related to the objective function. That's it. Rest it is not going to care, because if there is some data which is not required, it is not going. That is what is the main function of a PCA, right? Projection, each data point is projected into a new coordinate system resulting lower dimension representation. That's it will do lower dimension representation of the actual data as per the data characteristics according to the objective function. Dimensional reduction is data you now represent a lower dimensional space. That is the, I'll say, that is the only thing PCA does. It will do lower dimensional space, but you need to take care of that. It is, you are capturing the most important features of it, not the noise or not the irrelevant ones. So that's what it will do. It will do the lower dimension. It will represent it to a lower dimension, capturing most important patterns, and where it will capture the most important features or patterns of the variation, right? So that your model performs well. That is the single objective, guys. Let's move to the other section.
Yeah, sure, sir. Okay, let's see the advantages and limitation of this PCA. PCA offers several advantages, but it's essential to understand its limitation to apply it effectively in data analysis. PCA is a powerful tool for dimensional reduction, but it is not perfect solution for all suitability so situations. Okay, what is the advantage? It reduces noise and improves generalization, enhance performance of machine learning algorithms, reveals hidden patterns and relationship, and simplifies the data analysis. Yeah, since we are able to convert the higher dimensional data to lower dimensional data, it makes us reduce the computational cost, as well as the analysis also becomes very easier, right? Because computationally it is very less, and we can also make the analysis very faster. That's the reason it's a major advantage. Whereas the disadvantage, loss of information due to dimensionality reduction, sensitive to outliers, may not be suitable for non-linear data, and may require careful selection of components. So it cannot be applied to non-linear, but there is a technique. Okay, we're gonna discuss that. Okay, but it cannot be applied to non-linear. That is one of the disadvantage. And guys, one thing, even though I can say there is no loss of data, there is going to be some loss of data, because I'm going to convert the 1,000 dimension to only 10 dimension. There are going to be some loss in data, right? That is what another limitation. Okay, so I hope these are the advantages and limitation of PCA, and this non-linear limitation, right, in PCA, it will be overcome by the consecutive algorithm that we're going to see, I think, in the next couple of days. Okay, so yeah, this is all about the advantages and limitations of PCA. So yeah, sir, over to you.
Yeah, so advantages and limitations. So as we know, guys, we've been reiterating this particular point that everything has limitations. Everything has its do's and don'ts, advantages and limitations. There's a duality in everything, whatever you see. Even if you see the atom, it has negative and positive, negative protons and neutrons. There's a nucleus which has, like, they are moving around. So if you see that there's a duality in everything, that's by nature, right? So PCA also has its duality, like advantages and limitations. So it offers several essential understand limitations, apply effective in the data analysis. PC is powerful tool, dimensional reduction, but it is not perfect solution for all situations. See, everything has a probabilistic approach, guys, because everything is uncertain and we are always probabilistic. And as a data scientist, as a AI researcher, you always talk probabilistic. You might be talking before this and that, oh, 100% this and that. Now you don't talk because you will say probabilistic. There is a probability of X or Y. You can't say there is a probability of X only. So that is how you understand reality, and which has a flavor of uncertainty, which makes your conversation and your insights as a probabilistic approach. You always say probabilistic. Okay. So now, advantage is reducing noise and improves generalization. That's a very good. That means if it improves generalization, that means there is something, some concept coming up in our minds. What is happening? Underfitting, overfitting will be improved if it improves the generalization. So that you have to understand. Enhancing performance of the machine learning algorithm reveals hidden patterns, which is the most important job of unsupervised machine learning or supervised, I'll say. Reveals hidden patterns. So this is what makes machine learning, guys. All these techniques, these components, these algorithms are building blocks of machine learning. So they will have nature of what machine learning is, supervised or unsupervised. Okay. So relationships, hidden patterns, relationship, and simplifies data analysis. That is a that is why PCA is very powerful, but it is not fit for all situations. Okay, that there is a limitation. So limitations: loss of information due to dimensionality reduction, sensitive to outliers. Guys, we learned in advantages that it improves generalization, right? But in limitation, there is it is sensitive to outliers. What will happen? So one hand, it is going to help us in underfit, but then there is a overfit problem. So that so you can't be perfect at both the things, right? So you can see behavior may not be suitable for non-linear data. So it is suitable, usually works for linear data. Linear is which has which is linear. Linear comes from line, which is simple, linear, okay, and may require careful selection of components. So we have to select careful components of PCA. Otherwise, it will have limitations. So let's move to the other section.
Yeah, sure, sir. Let's move on to the next thing. Okay. Let's see the applications of PCA. Guys, again, it is not limited to this. Any field which has the application of data science, this PCA is gonna work. Okay. Let's see what are the applications of PCA in data science. PCA finds numerous applications in various data science domains, making it a versatile technique for data analysis, visualization, and model development. Image compression. PCA reduces the size of the image by selecting the most important features, preserving the essential information while reducing the storage requirement. Consider we are having a 4K image. It tries to pull the pixels and make it as only 360 pixel, but it has the same information. That is one thing that we can do by using PCA. Anomaly detection. Yeah, PCA identifies outliers or anomaly in the data by analyzing how well the data points align with the principal components. Okay, because like we will be creating principal components, right? If the data point which is not belongs to any of the principal component, then it becomes the outlier, so that we can identify the anomaly. Facial recognition. PCA is used to extract facial features from images, enabling effective recognition of individuals from larger dataset. Yeah, PCA as components, guys. Okay, I'm saying like it is a magic. Okay, it if I give my face to PCA, it has learned some facial features from my face. If sir's face I will give, it will learn some features from sir's face. If the person you are watching, right? If I give your face to the PCA, it gonna learn some features from your face. Our three faces is gonna change a lot based on PCA and the dimension that it gonna learn. Whenever we are giving a large group as an input to the PCA to predict the result of us three, it is very easily able to do it, because like it has reduced the dimension of our facial expressions that we are given through the image, and it is able to predict it very easily. Okay, that is why it is very helpful in facial recognition. Customer segmentation, yeah, PCA can be used to group customers based on their purchasing behavior, demography, and other relevant factors. So here, what we can do means here also, in order to find the customer segmentation, we can go and find how much depends on number of features. We're gonna find the customer segmentation. There also we can reduce the features in order to predict the customer segmentation. Just we can use only 2 to 3 features to produce customer segmentation. Okay. Hope you guys can able to understand. So this is what all about the applications of a PCA. So I think this is the last thing that we are having for PCA. Yeah, sir. Over to you.
Yeah, guys. So application for PCA in data science, AIML. So this is So it helps us image compression, anomaly detection, which we have already discussed. Can we go down or up? Yeah. Facial recognition, customer segmentation. Wherever you see all these behaviors in the industry, you can apply this PCA according to the behaviors. Okay. So in image compression, it will help uh, selecting the most important features, preserving the essential information, and reducing storage requirement. As I said, zip file. So you can just relate it because you might have done it a couple of times. So it will do such kind of behavior, but it is different. It's not that, but kind of. We also compress the data, right? So zip is all about that. So anomaly detection, PCA will identify outliers, anomalies in the data, analyzing how well data points aligns with the principal components. Then facial recognition, it is going to find the facial features based on the pixels, the design of the face, or like, okay, there are like there would be millions of faces, right? So it will have its own clusters and classifications. So it will try to match it according to, so it works very well with facial recognition. So it can be used in computer vision, it can be also used in self-driving cars, because the camera has to recognize a lot of pictures, a lot of people, a tree, where is the crossing, zebra crossing, this, that, right? So it's a blind person, you have to teach everything. Okay, so then customer segmentation, again, whichever industry, demographics, behavior of purchasing behaviors, or whatever relative factors, demography and other things, okay, segmentation and stuff you can do with this, whichever industry, wherever you require it. So as per the behavior of the industry, you can apply PCA in application. Thanks. Keep learning deeply with long-term objective function, with patience, persistency, consistency, and perseverance. And don't forget to subscribe us and press the bell icon and do all the quizzes, do imitation to the projects, do application, learn concepts deeply. So we have a 360-degree approach for learning, guys. Nobody else has. So we believe in your value of time and we want to serve humanity. Keep learning deeply. Thanks a lot.
Yeah, guys, so this is all about a PCA theory concept, that is black box of it. We have done with the theory and black box of it. Next session we're gonna talk about, like, we're gonna have a hands-on experience of this, okay, the coding part. Okay, guys, so as sir has mentioned, please make sure that you guys watch all the previous session videos and this videos so that you can have a better understanding. While coming to the next session, we're gonna have a coding part of this PCA. So make sure you guys have a better understanding of this two sessions, last session and this session, so that you can have a, okay, this is how the PCA works. So I'm gonna work on the coding. So like that, you guys can come there. So yeah, guys, so please subscribe to our channel, another thing, so that you doesn't miss any of our video, because like, and also push like press the push notification so that you will be getting the notification when we are uploading a new video. So yeah, that's it, guys. So thank you, guys. Thank you, everyone. So we will all meet in the next session. Bye, guys. Take care. Bye.